Yes. Um, Slideshow from client side. Now, now here we talk about the history of nanomaterial. आज ये 1991 के बाद this nanomaterials were discovered, and we are saying कि this is the new material discovered by the human being. But you can see our ancient people, they already knows about this nanomaterial. They know about the nanotechnology, but they have not written any book or somewhere not giving the proof. This is the nanoparticle and this is the nanotechnology purpose product is designed. You can see today also the Lycurgus cup. It is there in the Rome. That is the 4th century AD, and this is made up of the diachronic glass. Okay, with a mythological scene. It is there in the Rome culture, in the Rome church. But they have made it. But now today we are proving this is the glass which made up of the silver, gold nanoparticle. It is there inside. So why the old or ancient people using the metal in the glass to make the glass colored? है ना, ग्लास को अगर हम लोग को कलर्ड करना है तो दे वेर यूजिंग द मेटल्स. So while using the metals, and what happens, their colors becomes very different. So what is the beauty of this Leica gas? First of all, I will explain. If you lit the light on the cup, okay, so in front side it appears as a green. So if I lit the light from front, okay, on this cup, it appears as green. But if I lit the light from backside, it appears as red in color. Okay. So this is the beauty. And same a cup, but the lights we are apply on it from the front side appears green. And if you lit the light from the back side or from the inside the cup, it appears as the red. Now, why or how this is a magic? Now they says this is a magic, but it is not a magic here. So what happens if this cup is made up of the like gold is there or silver is there? So these are nothing but these cups contains the silver and gold nanoparticles. And because of this smaller size, if the light fall on it, that is we called as the UV light, which is there. So the color changes. That metal shows the different color. सो बिकॉज विवजॉर हम लोग बोलते हैं ना कि सनलाइट के अगर हम लोग प्रिज्म के थ्रू पास करें तो यू कैन सी इन द 7 different colors. Why there are 7 different colors are there in that visible light? So you know that every color is having a different wavelength and it appears at the different energy. So the same concept was there in the Lycurgus cup. So that 4th century AD people, they know about nanotechnology, they know about the nanomaterial, but they have not claimed this is the new uh, material and so on, or nano size material. Okay. In many church in France also and in Europe, so they are having a very glittered glasses using for the church, temples, or many other places. So that is nothing but the ancient people, they are aware about this technology. Then first time there was a lecture in USA, and that lecture was delivered by Nobel laureate, that is Richard Feynman. He was a physicist, and the lecture was delivered in December 29th, 1959. There is an annual meeting of the American Physical Society at the California Institute of Technology, Calicut, and Caltech. So there, the Nobel laureate Feynman was delivered a talk. The title of the talk was "There is a plenty of room at the bottom." Okay, this is the title of talk. And what he insists the new field of science to the scientist, and he says that he start working on the negative scale. not on the positive cell. So he says decimeter, centimeter, है ना, millimeter, micrometer, and go to the nanometer scale. So there is a plenty of things we have not yet understand. So there is a room. Room means there is a space, lot of things to do at this lower dimension. So that talk was inspired by many chemists or many physicists and many of the science field people, and they have started working on this smaller sizes. So that was in 1959. Now, in 1974, the word nanotechnology was coined by a Nario Taniguchi. ये टोक्यो का साइंटिस्ट था, जापान का. तो पहली बार इन्होंने एक शब्द का प्रयोग किया, दैट इज कॉल्ड एज नैनो टेक्नोलॉजी इन 1974. Now what happens in 1981, IBM company, today still this companies exist, okay, manufacturing of chips of computers and many other things. So this IBM invented STM, that is called as scanning tunneling microscope, okay, which can move single atom around. So we can see one atom and a single crystal by using this microscope. So 1981, that STM was developed, and all these three scientists, they have got the Nobel Prize because of this discovery of the what we called as the STM. Why there was a need of STM? Because Feynman ने तो बोला था कि नेगेटिव स्केल में काम करो. बाद में नेगेटिव स्केल में हम लोग काम कर रहे हैं, तो हाउ वी कैन सी दीज एटम्स? वी नो माइक्रोस्कोप, we can see only the micron sizes, but what's about below micro? There was no such instrument available to we can see the atom. So that's why that scientists, they have discovered the STM, and that three scientists, they will get Nobel Prize because of this. Now here in 1981, we started looking at the single crystal or single atoms. So after this, 1985, okay, the new form of carbon that is discovered, and that is we called as the C60, that is allotrope of carbon. Previously we know diamond, हम लोग को diamond मालूम था. We know graphite, हम लोग को graphite भी मालूम था. And after that, in 1985, Nobel laureate Kroto has discovered the allotrope of third carbon, that is carbon 60. But this was famous, ये famous हो गया कि it's a third allotrope of carbon. But it is not says कि this was the nanomaterial. Okay, देखो ये nanomaterial है, but इसका डिस्कवरी ज्यादा पॉपुलर क्यों हो गया? बिकॉज देर इज ए डिस्कवरी ऑफ थर्ड allotrope ऑफ कार्बन. लोगों को दो allotrope मालूम थे, डायमंड ग्राफाइट, और ये तीसरा आ गया कार्बन 60. उसको हम लोग बोलते हैं फ्लोरीन, है ना, फ्लोरीन 60. So fullerene was discovered by Kroto, Russian. He was a Russian scientist, Kroto, and the name has given fullerene. That scientist's name is Buckminster Fuller. He was an architect, and he has given the name to this molecule is fullerene. देखो, क्रोटो ने डिस्कवर किया, फुलर ने उसका नाम दिया fullerene. And again, this Kroto has got the Nobel Prize. Kroto को Nobel Prize भी मिला because the third allotrope of carbon was discovered. उन्होंने क्या बोला कि भाई in one fullerene there are 60 carbon atoms are arranged in a sphere made up of 12 pentagon and 20 hexagon. मतलब इसमें पेंटागॉन्स भी है और हेक्सागॉन्स भी है. जैसे हम लोग बोलते हैं उसको बकी बॉल, दैट इज फुटबॉल. आपने फुटबॉल अपने अगर आप देखेंगे तो फुटबॉल के सरफेस पे यू फाइंड द हेक्सागॉन and the pentagon. आप बोलेंगे सर why there are some pentagons are there in the football? So football, there must be a specific diameter of that ball. And to get that specific diameter, all hexagons are not work. So to get the spherical shape, so there must be some pentagon. And naturally, this is happens with this fullerene. So in fullerene, there are 12 pentagons and 20 hexagons. So we'll get the all 60 carbon atom together. Okay, and if the 60 carbon atoms together, so we called as it's a nanomaterial, because in nanomaterial 100 atoms साथ में आ गए तो भी हम लोग उसको नैनो ही बोलते हैं. Okay, 1 to 100. So, but this was not called nanomaterial that time, because it's a new discovery of third allotrope of carbon. And then people have started making this um, C60, then C120, then C40, C20, है ना, छोटा बॉल, बड़ा बॉल, बॉल में बॉल, है ना. So many people started making that. Once any scientist has discovered something, तो लोग क्या करते हैं उसको अलग 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 डायमीटर के, अलग शेप के, मैन्युफैक्चरिंग प्रोसेस डिफरेंट, ये सब करते करते रहते हैं. So that was the this one. This is the STM microscope for looking at this molecule. This is the Nobel laureate Kroto. He has discovered and he got the Nobel Prize in chemistry in 1996. And he make the soluble of this fullerene into a solvent, disperse it, and it can be used. So this is the structure of the fullerene. There are pentagons and hexagons. So in 1985 के बाद, so people started focusing on this buckyball, है ना. सब बकी बॉल बनाने लगे, छोटा बॉल, बड़ा बॉल, मैन्युफैक्चरिंग, कोई नेचुरल ऑयल से बना रहा है, कोई कैंपर से बना रहा है, कोई नाफ्थलीन से बना रहा है. सो मेनी पीपल हैव ट्राइड फ्रॉम डिफरेंट डिफरेंट मेथड्स. बड़ा बॉल, छोटा बॉल, बॉल को कनेक्ट किया, है ना, लॉन्ग पॉलीमरिक बॉल चेन, एंड सो ऑन. So what happens in the 1991. सो 1991, देखो बॉल कहाँ बना, रशिया में. अब ये रशिया में बॉल बनने के बाद मेनी पीपल स्टार्टेड वर्किंग. सो व्हाट हैपेंस, अगेन वी गो टू द जापान. हम जापान में चलते. सो जापान में दिस बॉल बिकम्स एन इलोंगेटेड, है ना, बिकॉज ऑफ द टेम्परेचर कंडीशन, प्रेशर कंडीशन. ये बॉल क्या हो गया, जो स्पेरिकल था, बक्की बॉल था, फुटबॉल लाइक स्ट्रक्चर था, तो इट गेट इलोंगेटेड, वो इलोंगेट हो गया. Okay, and it looks like a tube. It is hollow inside, and that's why it is called as the tube. So that was the 1981, and this is discovered by the Sumio Ijima. And Ijima was a Japanese scientist, and he discovered there there is a carbon nanotube. Okay, so this was the first material known to the human being. It is synthesized in the laboratory and called as carbon nanotube. Okay, carbon means it is made up of only carbon atom. Nano means its diameter is nano, that is 1 to 100 के बीच में है, नैनोमीटर के बीच में है. Okay, and it has a tubular shape. ट्यूब है, मतलब इनसाइड हालो है, and that's why it is called as a tube. So carbon nanotube is discovered in 1991 by a Japanese scientist, Professor Sumio Ejima. Okay. So after that, many people have started making the different types of tube. Okay, here is one picture. You can see it. There are many tubes inside the bigger tube, and that is we called as the multi-wall, है ना. एक ट्यूब के अंदर दूसरा ट्यूब, ऐसे हम लोग कितने रह सकते रख सकते हैं. So there is a single wall carbon nanotube, there is a multi-wall carbon nanotube, and single wall, multi-wall, they are having the different applications. So this was the first material known to human being or synthesized in the laboratory by Sumio Ijima, is a Japanese scientist. Then in 1993, again there is one breakthrough comes. People started making the quantum dots. Now you know what is meaning of a quantum dots and how these carbon dots are different than the nanoparticle. So quantum dots are nothing but they are again smaller than the nanoparticle. ये nanoparticle से भी smaller है. So it means they goes their sizes to 10 to the power minus 12. Okay, and that's why it is called as picometer. So we can say it's a pico technology, or it is also called as the dots. Okay, quantum dots. So quantum dots is nothing but the pico material. Now people are talking about the pico technology. Nanotechnology outdated ho gaya, because again the smaller size materials and they are having a very smart properties compared to nano also. So 1993 was known for the quantum dots. So either way, I can also say that to 1991, we can say there is a development in the organic chemistry, and in 1993, there is a development into the inorganic chemistry, because all that metals, है ना, cadmium sulfide, cadmium selenide, cadmium telluride, these are the semiconducting conductors started making by the people, and that's why this age is also we say it's a materials age, है ना, इसको हम लोगों ने material age करके नाम दे दिया for 1991 and this one. Uh, Here is the now you can see atom को पकड़ना बहुत difficult है because their sizes are very lower. Here, IBM company, that physicist, has used that 35 hexagon atoms. Hexagon के atoms उन्होंने ले लिए and they arrange that 35 hexagon atom, and they have lettered and written the name on a sheet, that is IBM. Okay, so become the first person to manipulate and position the individual atom. Okay, Don Igler. Okay, he is a physicist of IBM company. Less than 2 months later, he arranged 35 hexagon atom to spell out the letter to IBM. Writing those three characters took 22 hours. उसको 22 घंटे लगे इसको लिखने में, मतलब एक एक एटम को पकड़ के रखना है ऐसे सीट के ऊपर. It is very difficult because the size is 10 to the power minus 10, that is an angstrom. But today, this process would take about 15 minutes. That is, lithographic technique is available, so we can write this. So nano printing and 3D printers, such kind of things are now available. And we can write in nano lettering. It's very simple, very easy. So, but previously it took the 22 hours, but in now 15 minutes you can write in this. So that is the another development is happening. And again, you can just see, compare all our periodic table atoms and ions, and they are having that the sizes is 1 nanometer, but protein and all, they are 1 to 10 nanometer. Our DNA is also 2.5 to 10 nanometer in size, है ना? And all other things are larger size. So water molecule, if you say the water molecule is 10 to the power minus 1 nanometer, water molecule. Okay, and this is just comparison how this nano is different. So because of there is a development in the science, that is we call as nanotechnology, the evolution of new subjects also there. Okay, so initially we know about the physics, chemistry, biology, zoology. Okay, zoology and botany is the part of biology. If you combine this physics and chemistry, that we called as the material science. And then chemistry, biology, then there is a biochemistry, biotechnology, and many other. So the fusion of two subjects leads to the new subject. Okay, so material science, biochemistry, biotechnology. And here is one example. What we learn from this slide is dissolve the boundaries of subject. So you will do some innovation. Suppose I'm a chemist, I'm not expert of biologist, but somebody, the biology or biotechnology people join with me. So I fabricate the material, I will hand over to biotechnology. They develop it into the product. But if alone I should go for that product, it takes time for me to understand that biology or that zoology or any physics part. So it means if you dissolve the boundaries, then there is a innovation happen, and there is a Nobel Prize. You see in India, why the number of Nobel Prizes are lower? Because we are living in the compartment. हम अगर बायोलिटिकल साइंस के हैं तो हम बोलेंगे हम लोग बायोलिटिकल के, हम लोग इंटरेक्ट केमिस्ट से क्यों करें? या केमिस्ट बोलेगा कि व्हाई आई शुड कांटेक्ट विद बायोटेक्नोलॉजी पीपल, है ना? तो फर्स्ट ईयर बीएससी में बच्चे पढ़ रहे हैं कि भाई मैं मुझे केमिस्ट्री है तो मुझे बॉटनी नहीं जानना है. So that's why this NEP 20 came. So you should think beyond. You should have the friends of other subject, so you can more understand about the other subjects also. And you should start working in research. And if you reduce the boundaries, if you dissolve the boundaries of the subject, okay, so we have to reduce this horizon, है ना, ये इसको हम लोग को कम करने का है. So if you reduce this, if you dissolve this, then definitely the Nobel Prize or the new discovery for us. So I have put one slide for you, which is always our Professor A.K. Tyagi from BRC. He is talking about this scientist. The scientist's name is Venkatraman Ramakrishnan. Okay, so he studied initially physics in Vadodara. Okay, initially it is called as Baroda. Now it is called as Vadodara in India. Okay. Then PhD in physics in Ohio University. Then he worked as a PDF postdoctoral fellow in biology. Okay. And then again, he got the job in the biology, professor of Cambridge University of Cambridge as a professor. And he received the Nobel Prize in 2009 in chemistry. देखो, बंदा है फिजिक्स से बीएससी एमएससी किया है और पीएचडी भी फिजिक्स से हो गया. पोस्ट डॉक्टरल रिसर्च किया बायोलॉजी के अंदर, प्रोफेसर बना बायोलॉजी का और नोबेल प्राइज ले रहे केमिस्ट्री का. ओके, एंड दैट इज फॉर द स्टडीज ऑफ स्ट्रक्चर ऑफ फंक्शन ऑफ राइबोसोम्स. ये राइबोसोम्स का जो डिस्कवरी है, सो ही हैज डिस्कवर्ड दैट राइबोसोमल डिस्कवरी एंड इट्स फंक्शन एंड स्ट्रक्चर. सो हाउ इट इज पॉसिबल? So that is only possible because he's having the collaboration. He has the knowledge of physics, he has the knowledge of the biology, and again he has developed with his friend, with his collaborator. There are three scientists, and they are worked together, and they have discovered this structure and function of ribosomes, and that was the Nobel Prize in Chemistry, and 2009 Nobel Prize in Chemistry for our this is the Indian scientist born in India, but now he's a citizen of UK. So we can't say कि ये हमारा Indian का Nobel Prize है. No, okay, because he has got the citizenship of the UK. But I met him, scientist I witnessed in IIT Bombay when he was came to deliver a lecture in Tech Fest. Every year there is a Tech Fest in IIT Bombay. So whenever you will get opportunity, please go and see many such scientists, Nobel laureates, they are inviting, and you will be a witness to understand from these people. So most widely used definitions, I already explained. The nanoscience is the study of phenomenon and manipulation of materials at atomic or molecular scales where the properties differ significantly from the larger scale. Technology are nothing but is a design, characterization, production, and application of structures, devices, and system by controlling the shape size at nanometer. So this is all about the history of nanotechnology, and we will stop it here. आज के लिए हम लोग इधर ही रुकते हैं. And in the next lecture, we can talk about the classification and the fabrications and other processes. So any doubts, any difficulty, you can just tell me. Okay, I will stop recording. Stop.